Welcome back. Advent of Core 2016. Day 24, Christmas Eve, Air Duct, Spelunking. You finally met your match. The doors that provide access to the roof are locked tight. All of the controls and related electronics are inaccessible. You simply can't reach them. The robot that cleans the air ducts, however, can. It's not a very fast little robot, but you reconfigure it to be able to interface with some of the expired wires that have been routed through the HVAC system. If you can direct it to each of those locations, you should be able to bypass the security controls. You extract the duct layout for this area from some blueprints you acquired and create a map with the relevant locations marked, your puzzle input. 0 is your current location, from which the cleaning robot embarks. The other numbers are in no particular order. The locations the robot needs to visit at least once each. Walls are marked as hashtag and open passages are marked as dots. Numbers behave like open passages. For example, so if you suppose you have a map like the following. So you have like 0.1, dot 2, dot 3, dot 4. To reach all the points of interest as quickly as possible, you would have the robot take the following path. 0 to 4, 2 steps. 4 to 1, 4 steps. It can't move diagonally. Okay, so we go 4, 1, 2, 3. Since the robot isn't very fast, you need to find the shortest route. This path is the fewest step in the above example, total of 14 steps. Required to start at 0 and then visit every location at least once. So it doesn't really matter the order. I don't have to do 1, 2, 3, 4. I just have to meet them all. Given your actual map and starting from location 0, what is the fewest number of steps required to visit every non-zero number marked on the map at least once? Can visit more often as well. I have a giant map. Okay, it's not that bad, but a bit big, similar. I think, yeah, there's like a wall or it's like a maze. So I just have to figure out where to walk, where I'm able to walk always. Hmm. Interesting. How do I do it? Here's a 4. Here's a 7. 3. That's interesting because I know how to write an algorithm to find the shortest path between two nodes. But 0 to 4 to 1 to 2 to 3. Maybe more simply, you should just walk in all directions. Including walking backwards. And stop once you've reached um, all the markers. I think that should work. Let's see. We can do this. Um, ah, um, each line, I guess, see how it looks. Yeah, we need, well, let's start with this one. Just check it work. Then we can kind of position, start at 1, 1. And then I can just check. Do I have the dirs? Dirs equals list of 1, 0, minus 1, 0, 0, 1, 0, minus 1. And then do I have plus? Um, A dot y plus b dot y. Member. Here. And then this. So I can do pos plus pos. Cool. Then I look at each direction. I can go pos plus d. That's the next one, and then I can see is it valid based on, well, basically I just have to check lines. I can map the lines. What I want is I'm confused. Lines dot for each character, and then give you like a pair of I don't need to do this. I can just do lines. I can just do lines of next dot y and next dot x. Is the character. Let's print this, see what happens. I have a dot here and a dot here and then a hashtag here and here. So I can just say if this character is a dot, basically I'm filtering for those, right? Filter, this character is a dot. I can map it first, then filter to get the, so this, and this is the next. And then I have the next options, which are 2, 1, and 1, 2. Okay. That took longer than I wanted it to. Okay. Then can I make a function, right? Get options for my position based on the lines. So then options for each, I just go there. And then this has to be some kind of function. And I just collect paths, I guess. No, I don't care about paths. I just care about how long it takes. While done is false. While not done, there's like a current list. There's just pause in there right now. It should exist. Maybe. I do have to collect the paths though. Or at least indicator of which ones I've visited. Maybe it can be like path. It's a point and a list of what are they called? Controls. List of int. Okay. Okay, and then I just say then current equals get next of current. And in get next, I do this stuff here. Which is a list of. Oh, I have to be useful. Just bar, I guess. Path of P and empty list. Legend. And then that's the path. It returns a list of paths again. I get the options. Okay. Next equals mutable list of paths. Then options is get options for current for each of the current paths. I just get all the options. The lines are just the lines. And options for each. I can just check if not hashtag is better. Check if is number. Can I find it out? Yeah. Opt is, I can check again in lines. Opt X, well, opt Y, opt X. If this is not a hashtag, a dot, then it's a number. So I can fetch it. Which I have a current list. Is control. Plus this one. Oh, I can make it a set. Set plus whatever this is. Maybe control. Else. We just keep it. And then we just map add opt. Well, the path with opt as a position and controls as that. Okay, what's going on here? Controls is a set of thing, and then this is a char. Ah. Well. That's fine. Empty set. Cool, cool, cool. So we can make a new list for each current position. We check the position and what options we have to go. Then we go into those options. Once we're there, we can check if we've hit a control. If we did, then we can add it, otherwise we just keep the same. And that is our new path. Okay, and then we return all the next ones. And that's it. Then we did this. We get all the new path options. If current.any it dot source dot size equals limit, whatever it is. Then we're done. Then we can print I. And then in our example, okay, that's the limit small. Limit is 4. Okay, this is a bit confusing with the 0. Mm, okay, how about we just add 0 in? Because we have it. Then we have inclusive, and then we have 5. Okay, we have 14. I feel like that's wrong. Ah, no, it's 14. Cool, let's try that one then. Just don't know what the limit is. We have to look for numbers. Okay, it's 7, 6, 5, 4, 2, 1, and then we have a 0. Ah, the 0 is actually the middle. Do we start at 0? Starting at location 0. Damn, I have to find 0 first. I'm too lazy to find 0. We're in row 12 and 35. Print lines, and 12, 11, 34. I don't get it. Why can't I see it? Okay, it's probably doing something. Okay, it's a dot. Wait. No, it is a 12? 35? Okay, I don't know what's going on. 33. Okay, then we just start there. 11 and 33. Why is 33? Ah, because this is after it. So this is 34, so it's 33. Okay, got it. Let's see what it does. Mm, here, look, I can do this. I can do this. Acquire equals 0. Okay, limit 5. Okay, we can't even find 5. Damn. Oh, I have an idea. I'm always going back now. Oh, I only should go back once I've found um, another one. Because currently my algorithm, it would just go, also just go back and forth here. Could always go all the way and find something and then it requires me to keep track of my whole path. But it will help to okay. Let's do it. Let's keep track of the whole path. Wait, no, it has been list. Wait, list P. Okay, so list of pos is the path. Then we go here. List of paths. I get the latest one. Oh, why does this P not good? But whatever position is. The path. I can just take the last one and I have the same. I don't know if I need the path. Ah, here, and now I can do a filter not. I'll just do a filter. It not in c.p. I mean, maybe I need to go looping or something like that. Hmm. Damn. Okay, I have to keep track of the path since my last item. And then as soon as I have a new control, I clear the path. And I can keep it in one thing. Um, Path is also we'll just do this as the whole path plus me plus the new one. And then that's the path. Let's see. Why am I not trying it for this one? Okay, my other one did work for that. Let's see if this new code works for that as well. 11 out of bound. 11. Yeah, okay. Like this. Ooh, this one takes longer. Okay, limit is probably too high. Oh no, limit is still 5. That's fine. Okay, let me think about filtering again. Okay, let's see if it works without filter. Ah, wait, I have to do this. Yeah, yeah, now it works again. Wait, that's without filter. Let's do this. Okay. Now we go this way. Let's see. This is good enough, maybe. Print line I cur dot. See what it looks like. Okay, I'm only finding 3 is really slowing down. There's just too many options still. Wonder what else I can apply that I don't go back and forth. Hmm. I think keeping track of stuff is not the issue. I think limiting the options is the. Hmm. So look at some outputs. I'll just do. And then I just print everything. Hmm. I can also do. Okay, so first we have 1 point. Then we have 3. All directions. Then we found 5 already. What? Where is the 0? Okay, that's already weird. Why? There should only be 1. Looks like it's not correctly. Hmm. Okay. Just do it myself? 4. Filter. have him up 4 times, and then we check. What's this? Check it now. Not 1233. I think X is there. I think it does matter. What's this? I think it's X and Y now. Because this is X. This is Y. Okay, let's check now. Okay, now we only have one. 1135. And isn't there another place where I do this? Here as well. I think this also needs to be this way then. Okay. Odd. Well, it makes more sense now. Let's just run it again. And I can maybe not print everything. Zero, 1, 2. It's easier to look here. 0, 1, 2, 3. Oh, we need to trim the space of options somehow. Check once more if this works still. 14. Wonder if I can learn something from this. Not really, it's very, very simple example. Wonder if I found one option, if I can just like remove all the ones that haven't found one yet or something like that. Um, And I set it to true. If someone found it, I just remove m is x dot map it dot size. And then I just do this. Let's see. If I mean it kind of okay. Printing a lot. Well, I'm getting way further, but also not that much further. Let's do something else, like that's more clear. Let's see, where is it going at the beginning? I feel like as soon as I find another one, I should be fine again. Let's check. Also, doesn't seem to me like I'm not allowed to go back. It feels like it's a bit too. Um, look, anything that hits a dead end. So if it's not longer than there are no options left, I should kick it out as well, maybe. Not carry it around with me. Let's do that. I have a lot of lists here. Let's say that I always filter out. I know. That's fine because I'm not adding anything that doesn't have an option. I'm filtering those out already. I have a dead end. So that's fine. Let's say it goes here and it goes in all directions at the same time. It also goes here. All the different options. Oh no. Maybe there's some kind of more simple solution. It's like two. This example also does it like that, where it's like find the shortest path between 2 points. Maybe I just have to find the shortest path between all of them and then filter out and just try any combination and see what's the smallest. That would work, maybe. Okay, so I'm going basically I'm just doing this until I find one. Um, well, I'm at 2 basically. And then I have the shortest path between mm, 7 is the biggest one, right? And then 8. So I need controls equal set of 0, 1, 2, 3, 4, 5, 6, 7. And then I need pairs of them. Mm, okay, it's easier to do um, it map, map, flat map. Oops, stop. Funny. Okay, I need a digit to try, I think. Then we have this 1, 0, and so on. I like the other way around. 0, 1, 0, 2, 1, 2, and then 6, 7. Okay. For each of those, I want to find the Okay. Then we have a short path between 2. Find on find stuff for each line. Index J line J C. And I check if my brain's not right. I have it here. C in let us do control. Let's just say this is like 0. Then let's do um, there's a function. Private fun find control, which is a car, a string, return the point. Okay, here we go. Okay. Then we can just get, for each control, we can just get the points that we need. And then we just start. Here is path. Here. The point is, this is a function as well. And I can like input the point. I can start and then doesn't start. And it only ends if any contains .p dot contains the end. Then we're done. We don't need the limit even. Let's do done is this. And then we return I. Bam. Okay. Now we just find. Okay, now we can do this. We have the pairs. For each pair, and we find the path. Which is pair dot. No, it's not that. Do this. Find pair dot start first and the end. And then that returns some kind of int. And then that's the list. So now we can map the distance from each pair to dist. And we can see that is. But let's try it on the small example first. Here I should only go to 4, and then we have 2, 12, 14, 2, 14, 16, 4, 2. And then we can zombie together a solution of the smallest one. So here we can go 0, 1. Yeah, we figure out the rest. No, actually, let's figure it out now. We can from here. Stop. Okay, let's patch this together. Basically, just have to connect the dots now. So you have to say start at 0 and go. Yeah, how can I connect them? Res dot. kind of have to find paths in this again, right? Basically start at 1. Zero. And then I check from my result list where I can go. For each of those options, I go um, um, I go add to my current list, kind of. Oops. And then I say a function again. No, that's fine. Well, not done. Cur equals and next of cur. List of car, and it's kind of like a list of car and something else. So I have a new thing which is new thing, new path, which has a path of list of characters and a distance, which is int. I can just add to that. And this needs to be p. And I'm starting at 0. And I need these results here, which are list per cha int. Okay. Taking the last one. For each new path, check the options. For each option that I have to go, I just add next, a new thing, which is this current guy's path plus this options. This options last character. Yeah, ignore the distance. Oh, I could map this into something cooler. So this is also something. What do I call it? For each of those places, find the shortest path. Shortest path of a pair, which is a pair of car, distance. I can map it to pair and a distance sorted by a dot dist. And we can already do a list of short paths. Pair is the first of the pair, the same as in my class where I'm currently at, which is the last character. Then can add that options. And second character. The first one matches me. I move on to it, and then the second one is added to my path. And then I need to add a dist, which is the option where it's my distance plus the option distance. That's it. This returns the next list of NPs. Ooh. Okay, now I just have to pass this in. Current, okay, what's wrong? Okay, here we also have a list of a new path, which is a path with distance. Cool. And we don't really need I. Well, in this case, we just need to check go dot max of it dot path. Limit print line her. I don't know. Let's see what happens. 0, 1, 2, 3, 4. Distance 30. Okay. That didn't work. Well, it kind of worked. Okay, now I have to just find all the paths. How do I know I'm done? Empty. Yeah, I throw them away then. Hmm. This maybe? No. Damn it. How do I get them? I just keep them always, but then I have so much stuff. Um, mm, so instead drin, dann mache ich so. Paths, add all next, then cur equals next. So, and then I can print all paths. Then I get the 14 one at the beginning. No, it doesn't work. Why not? Oh wait, I have to also put um okay, what is this? Then I go Now it goes back and forth, I guess. Um, there's always a next then. Heuristically. Uh, uh, I think you need to have another cool algorithm that is smart about choosing distances. But I'm also thinking I have some kind of weird bug in my thing. Oh yeah, I'm also printing all paths. Clear. Hmm. Get my charger. I think we almost got this. Um, um, we can just take this end, I think. Path, distinct, size, limit. Print those. Mm, well, we just need to take one actually and print it. Damn. Okay, we didn't find the correct path then. Let's check again. The correct path is 0, 4, 1, 2, 3. 0, 4, and then 4, 1. Okay, so if we're already going over the duplicates, then we actually have 4, 1. So we don't want to. Well, we will be able to find the correct one in the number of times. And 5. And we shouldn't repeat. So we can trim harder here. We want to go somewhere where we haven't been yet. And I can even put here it. Right. There's an option. I look at the first one. Does it match me? Then I can take the path. If that option is paired with second, needs to be not in my path. Okay. Um, don't I find the correct solution? 0, 4, 1, 2, 3. 0. 0, 4, 4, 1, 1, 2, 2, 3. Okay. I want to find 5. I have 1. Oh, maybe I should try one more. Wait, what's a 0, 1, 4, right? Why does this one not continue? 4. No, I need 0, 4, 1. 0, 4, 1. Here, this one. 0, 4, 1. 0, 4, 1, 2 has distance 20 here. That's strong. Why is that the case? 0, 4, 1 is distance 6. And 1, 2 has distance 14. Oh, okay, so this is not working. Find path. Oh, mistake. Fetch. Maybe like this. Still a 14. Um, let's go. Debug. I'm gonna go for 1, 3 to 1, 9. What do we do? Control is 1. We start with current size, and we go here. Then we go. We just have 1. So the last of this path is this guy. Get the options. What options are there? Yeah, go left or right. Okay. Each option. We check the dot. Okay, let's just go continue. Here, these 2 paths. Cool. Now I have 1 option for one of them, 1 option for the other. Okay. Continue. 1 option for one for the other. Whoop, I was the only one. Oh, we only have one left. Huh? Start again. Okay. We have one at the beginning. Okay, cool. Then we have two. Each have one option. That's cool. No. Then we're already out. We don't care about this anymore. Actually, uh, one of them is fine. No, I think they're all not fine. Okay, let's just run this. Good, now we have 6. That's what we want. Okay, so I had an optimization earlier that didn't work. So now we have 14. 0, 4, 1, 2, 3. Let's go. Then we can go to the real one. See what happens. The limit maybe is wrong. But I'm curious if it does anything. Like, for example, does it even find all the paths? Do I maybe need a different algorithm to find the shortest path? I mean, I definitely don't need the path, like all this data that I'm keeping. I think I don't care about it anymore. I just need the current position. And I don't know if I need the set of characters. Hmm. No, it's nice to have the path because I don't want to go back. Yeah, I don't want to go back. Keep the path. Java heap space. wonder if we find any. Print line. I think I probably overcomplicate something here. I actually don't need to check the control at all. So I already know what I'm looking for. I can just say it's also confusing, I think. Hmm. I'm just gonna clean up a bit and try to simplify. What if it does turn out to be faster if I just uh, yeah, I just keep the path. Actually don't even need to do anything. I just keep point. I just have a point, list of points. Where is it? Oh no. I just have a list of points. Visited is return of start, which is just a point. Here I don't care about path, I just want start. Then Just pass visited here. Bam. Point P, bam. Just more simple, just breadth first search basically. For each point, that's the P. Care about that. I care about something else. It not in visited. And then I add option. Next. Yeah. And then any it equals to end. That's it. That should be better, I think. Oh, wait. I never add to visited. Next this. And next. I'll just add cur. I'm confused. Let's just try it. Cur is here. Get the new ones. Add them all to visited. Because I have. If any of them are the end, we're done, and that's how far it's away. We still can't even reach one. That's crazy. It's the first pair. 0 and 1 probably. Some way to easily get it. What else am I missing? Is it working? It's not working at all. Why is there Valcor here? What? Okay. Let's restart again. 0, 1 is 174. Okay, we're getting some results here. That's great. I hope I updated the limit. I didn't, I think. Yeah, limit 5 here. Is it worth it to stop it? Probably. 7 or 8? 8, I think. We'll just wait till it's done, then I can copy this, and if the second part doesn't work, I can just parse it and don't have to run it again. Oh, cool. Let's take this. And this here. Whoa, I don't even have to parse it. I can just do this. I can just replace that with something like that. Char was expected. This? Yeah. Okay, maybe I can do the same thing again. Okay. Now we're talking. Okay, so now we have, what do we have? Is this the solution? The smallest one? 448? Let's try it. Whoa, okay. That was insane. So we had to run 2 breadth first searches. One is this one, where we find all the shortest paths between each of the points. And then I was too lazy to run it again. So I just have all the shortest paths with the distances here now. And then I run another breadth first search where I can just figure out a way to combine all the paths in the shortest way. Of course, if you leave the cleaning robot somewhere weird, someone's bound to notice. What is the fewest number of steps required to start at 0? Visit every non-zero number marked on the map at least once and then return to 0. Okay, so now I just need to say that I want to add all the paths together, but what if I can just do 9? And then it can be 0 or it's 0. Or um, and then I want to find a path where that is a limit and as a 0. This here maybe? Let's see. Okay, I'm not finding any. That's weird. I'm also going only 6 times. Seven times. Oh shit, I didn't want to print them all. What? Let's do it again. Okay, I'm not finding any. Let's do 9 or something. Okay, this probably takes too long. To 8. I'm not finished. Did it? I wonder if it's good enough. Or my path size equals 7, greater than 7, and I'm connecting to a 0. Let's see. I can go one further maybe. I can't find any. Wait, do you have to go 7? 6. I was just throwing away current always, so wait. There's 7 numbers, right? So I have to go. I'm not even finding anything anymore. Oh, damn it. Wait, distinct? That's okay. Let's leave it 8. And then we go but last equals 0. Okay, and then we have to mess around with this, I think. Okay. I'm not sure. think in 5 you can't, in 7 you can find an 8. One, three, 1, 2, 3, 4, 5, 6, 7, and we go back to 0. Go exactly one step further. I think that might be it then. Let's try. Yes, that's it. Okay, so we just had to do some kind of shenanigans down here to find a path that has a 0 at the end. Alternatively, so either the second one is not in the path, which we don't want it in the path because then we repeat ourselves and we don't want to repeat our path unless we're at the end, then it's okay to repeat ourselves once, so we add a 0. We add that, and then we just go one iteration further because you know that it's going to take 8 times to find a path with exactly 8 or 9 entries. 9 entries because one entry is in the beginning already. Then our limit is 8 because the distinct path size is limit, put its end with a 0, and then we sort by the smallest one and take one. That's it. That was quite rough. 2 breadth first searches, but we got there in the end. Have a nice day.